In this video, we're going to look at example 3.1 and use R to explain the details. So here is example 3.1. Note we had 30 students and their quiz scores. There are 30 students and there are their quiz scores, and we have the sum of all 30 right here. And in there we looked at the mean, we looked at the standard deviation. We even looked at a plot on the next page and noted that they looked consistent with a normal distribution. And if that was true, then about 95% of the observations should be within 2 standard deviations of the mean. So in order to do that, we need to find the mean and the standard deviation of these quiz scores, and then we can identify what plus or minus 2 standard deviations looks like. So we'll pop on over here to R. Actually have the data, so I'll make something called Q scores and say read.csv file.choose. It's easy to select files, and I'll say header is true because I've got the data sitting right here in something called chapter 3, and there it is. Chapter 3 quiz scores, and actually I'm going to use the CSV version here, so go in, and then I will always check. It's always great to have a sanity check, make sure you've got some scores, and sure enough, that's them. So, very simply, all we need to do is do Q scores, $, quiz. That'll give us the quiz column, and do that, and sure enough, 7.42, which recall is this guy right up there, 7.42. We also said, hey, let's look at the standard deviation. How much do the quiz scores vary from score to score? And it thinks about 1.14, but let's verify. So that would just be SD Q scores $quiz. And sure enough, about 1.147531 is the estimate of the standard deviation. These are both X bar and S, both estimates of mu, the population mean, and sigma, the standard deviation. So now that we've got an estimate of the mean and an estimate of the standard deviation, we can figure out what plus or minus 2 standard deviations is away from that. So 7.42 minus, just being approximate here, 2 times, for a normal distribution, that would be about 1.96, but that's pretty close to 2. So 2 times 1.147531. Sometimes it's nice just to type some stuff in. So you do that, I get about 5.12, and I can just hit the up arrow, right? I just hit the up arrow and get this back, and do plus that time, and that'll give me about 9.715062. So then all I have to do is say, hey, let's, so R says true is a 1 and false is a 0. So if we sum a bunch of trues and falses, it'll just sum up the number of trues. So I'm going to put in here Q scores, $quiz. How many of those are greater than 5.124938, and how many Q scores $quiz are less than this thing. Right there. Now, R can get a little touchy sometimes. Sometimes it likes for these to be in brackets. I'm not even going to check it first. Just do a little work in there. So after it does that, it's going to count up, hey, how many of these are both greater than 5.12 and less than 9.71? And that turns out to be 29. And 29 divided by 30 is about 95%. Of course, it's not going to be exact. It's very discrete. It's only a sample size of 30. But that's pretty darn consistent with a normal distribution. Maybe we should have done this. Always a great idea to plot your data first. Got a little ahead of myself there. So we can go ahead and plot it here with a histogram. And that's about what we see. Now, somebody might say, hey, this looks a little more left skewed. What we're looking for here is something that's consistent with a normal distribution when I only have 30 observations, right? I don't expect it to be exactly symmetric with only 30, or with only 20, or with only 10. If I had 300, yeah, I'd expect this to probably be a little bit more of a normal distribution with this kind of standard deviation. If I had 3,000, right, the more I sample, the more I expect the histogram of the sample to resemble the distribution of the population. But that is great. That's just looking into some fundamental statistics here with example 3.1. Great job. See you in the next one.